Hello everybody, today we're going to be talking about conditionals. And conditionals determine what statements of code get executed in your program depending on whether a variable is evaluated to be true or false. And then in previous sessions we've talked about these true or false values being called booleans. So let's do something really simple. I've got my Spider environment here. I'm going to start writing my Python code, and let's just do something, the simplest case that you can do. So if true, let's print condition is true. And if I run that, we can see that we printed out the statement condition is true. So some notes here is that here this is a built-in function if, a built-in statement if, and then here's my condition is true, and then the construct or the syntax of an if statement is you have a colon there. And then notice that when I hit return in the editor, it spaced over 4 spaces and then started a block of code. So this baseline here, this indentation from the baseline, is meaningful within Python, and it basically means this block of code is associated with the if statement. So let's now extend this and say condition is equal to true, and we will then say if condition and use double equal sign, and double equal sign means return a Boolean value for the test case. Does condition equal true? If that's true, then return a true and then execute the code below that. So now when we run this code, we go back up and run the code, we print out condition is true. If I was to say condition is false and rerun this, there's no output. So let's add in a statement called an else statement, else. So if that condition is not true, what do we want to do? Let's say print no match. And rerun this, and we see that we have no match as the output. So let's extend this a little bit further, and let's say condition is equal to a value of 10, and say condition is equal to true, else if, and else if is shorthand elif, elif, and then we need to put a conditional statement. So condition is equal to 10, then we will print out condition is 10. So we can extend this to if, elif, and else. So you can have as many elifs below your if statement as you want. So in other languages, you may be familiar with a case structure or a switch statement. Basically, by extending this real concise code with ifs and else ifs, no case structure is just needed within Python. So it's not a switch statement is not a part of Python. So we can see that the output here was under our else if statement of condition is true. So summary here, these double equal signs basically says return the condition, a Boolean value, evaluate if that's true. So and then there are other types of conditions that we should consider looking at. So let me copy over some of these conditions from my snippets, and we'll simplify this code a little bit. We'll put those up top. So we just showed that the comparison value of 10. So let's show greater than equal to is greater than equal to, we could say 100 here. And if we put in a 200 for our condition, go ahead and test that. And then we've output condition is true is what we have under the condition is greater than equal to 200. There we go. So not equals is exclamation point equals. So if we wanted to say not equals 100, and it would go through our if statement, else if, and else, and we should see a condition is true because 200 is not equal to 100. Greater than, pretty straightforward. Less than, greater than, equal to. We can try that. And once again, condition is true. Less than, equal to, and we will see that there's no match. So you get the idea of these are the conditional statements that you can use. Now let's discuss this object identity of is. So is really tests whether the object is actually the same object in memory. So let's simplify this a little bit. And if I was to say create a list called list A equals 1, 2, 3, and B equals to 1, 2, 3, 2, 3, and then we were to say A, print A equals B, what would be the output? Or A is equal to B, and print the output, we see that this conditional is true. Now, if we were to say A is B, we will get the condition is false. They're not the same object. And to show that they're the same object in memory, we can use this built-in function called ID. So let's do this. Print the ID of A, and then print the ID of B. And let's print that out. We can see that they have two different codes for the object. If we wanted to make these the same object, we can say B equals to A, and then we print these out. We can see that they're exactly the same identifier, object identifier, the ID. So this can be useful, these conditional statements can be useful in evaluating and controlling the structure and execution of your code. So let's do the next step here, which is to understand the concept of and, or, and not. And so if I was to create a code that said x equals 10 and then logged in equals true, and I wanted to say I needed to have both of those conditions to be true to execute, I could say if x evaluates to 10 and logged in is equal to true, execute this block of code, print both conditions are true. We're going to run that, both conditions are true. So, the or statement is pretty straightforward. So if I was to use the or statement rather than and, I could say either one of these were true. I want to see the output. Both conditions are true. In this case, one of the conditions is true, not both conditions, but one condition is true. So either x or logged in can be true. So let's say false here, so neither are true, and then we could output an else that says print neither are true. Or maybe no match is simpler to type. So there we go, no match. Okay, and then this may be a little confusing, but if we were to say if not logged in, execute the next block of code. And so you can think of the not as negating this. So if not false, which would execute to be with not false, which would be true, this would be executed. So we could say please log in, something like that. So that's the use of and, or, and not. And the other kind of thing to realize here is that you can have multiple ands in one statement. So you could test 3, 4, 5 conditions in one if statement. Okay, so the next thing I'd like to discuss is what actually are some things that are evaluated to be false within Python. So I've got a little bit of snippet code, so let me copy this over and we can walk through this. I'll deliver the snippets code to you so you can do the same as well. So let's clean this up and make it a little bit cleaner for us to look at. So these conditions are evaluated to be false. So if I set the variable condition to equal false, of course, if condition, so if that's true, it'll print that, or else it'll print false. If we're to do that, so evaluate it to false. So here are some kind of tricky things to realize is if condition is none, which is a key word within Python, it's going to evaluate to false as well. Or if I have my variable equal to 0, it will execute the false condition as well. So evaluate it to false. So, but any other variable value, integer value, 70, is evaluated to true. So that's something to realize in your code. So you can write efficient code is to realize what will be evaluated to false. Now here are some other things that may not be as straightforward. So if you have an empty string, that will evaluate to be false as well, but anything inside of that will evaluate to be true. Same thing for tuples and even an empty list. So if I was to say an empty list, whoops, delete that, an empty list, and to run the code, get false as well. And an empty dictionary. So knowing this allows you to write, you can test for conditions, and if there's, and then create a dictionary, for example, and if you test for the condition and it was false, you could have an empty dictionary and pass that into a structure later on. And so that allows you to write more efficient code understanding what evaluates to false. So in this session, we covered using conditionals and highlighted how to use the and or not, as well as took a look at what statements evaluate to be false within an if statement. Hope this was useful, and until the next time.